Boom! Oh boy, I hope I woke you up a little bit. Had to wake myself up there for a moment. Well, I hope everyone's doing great. Here's what we're going to be doing today. I have stumbled upon a new piece of technology that I'd like to see how it works. And so I'm going to be using it today to interface with you guys. Now, how does it work? Well, it's kind of a video streaming service that you guys have obviously probably used YouTube before. It's just like YouTube, but the difference is that not only can I see who exactly has watched the video, I can also see, I'm going to embed questions within the video that will allow me to determine if my teaching was effective and if your learning was effective. So it's kind of a threefold actual tool that I'm going to be using. So I'm excited about it. I'm going to do a lot of work to get it up and running, but we're going to see how this all plays out. So what I'd like you to do, if you haven't already, I want you to pause your computer and I want you to get out your vocabulary packet and your example packet. We're going to be using both of those. So go ahead and pause the video right now and go ahead and do that if you haven't already. Okay. What we're going to be talking about today primarily is going to be midpoints. And then from there, we're going to ask the question, can we determine where on a line or a line segment would a point lie if it was located approximately maybe a third the way down the line segment or a fourth or 2/3 or something like that. Okay? And we're going to talk about how to understand and know how to use those. And so what I really need you guys to do is pay really close attention to what I am saying, how I'm doing things, and then you're going to answer some questions like I said a moment ago. Okay? Now I do want to apologize. This is the first video I've made this year, and the technology isn't where I'd like it to be. I need to talk to Mr. Trusty about it and see if we can get it up and running. But go with me. I think you'll see what's happening and hopefully be able to understand everything really well. So the first thing that we're going to do today is we're going to talk about midpoint. Now, if I were to say, what's the definition of midpoint? I would hope that you would break the word apart and say it's the middle point. And you're exactly right. You might want to put that right underneath the definition of midpoint, in parentheses, the middle point. Okay? But let me give you the actual definition so you understand what's going on. So the definition of midpoint is as follows. It's a point located halfway between the two endpoints. Okay? A point located halfway between two endpoints. Now what you might want to do is to go ahead and make a point, draw a line segment, make another point, and then estimate, I believe that this right here is the midpoint. Okay? Alright? Now, in doing that, you can go ahead and put down that those two would have to be equal. Okay? And so, in this case, if I were to go ahead and do A, B, and C, okay, those three, B would be the midpoint of segment AC. Okay? Halfway in between. The midpoint formula, down here in parentheses, you might want to go ahead and throw in some parentheses and write this down. If it's halfway between, a lot of times we can think of the average as the middle number, right? And that's exactly what the midpoint formula is. So I would write this down in parentheses, average of the x values, comma, average of the y values. And I would put that in the parentheses there. Average of the x values, comma, average of the y values. Now I'm going to tell you this. Some of the formulas will be given to you on the air test. I don't believe this one will be. I think it's too simple to forget. Just think average of the x values, average of the y values. Now, what is the formula exactly? I'm going to write it out here for you. It's going to be x sub 2 plus x sub 1 over 2. And you see it there? You're adding two numbers together and dividing by 2. That would be calculating the average of the x values. Okay? And then for the average of the y values, y sub 2 plus y sub 1, and all that's over 2. Okay? So again, adding the y values together, dividing by 2, the average of the y values. So I hope that's making sense to you, the midpoint formula. Now, segment bisector. What is a segment bisector? Well, I like to break words apart to understand their meaning. So I would underline the prefix bi. Now, what does bi mean? When I think of bi, I think of bicycles. Okay? So I'm going to go ahead and say a bicycle has two cycles or 2 wheels, okay? So I'm going to go ahead and put down here maybe just 2, okay? Now this other term over here, this word right here, sector, is a section of something. A lot of times we say a sector is a portion of a circle. It's kind of like in baseball, you've got the first base line, the third base line, and then you've got the home run fence, so you've got a portion of the circle there. And so we're looking at 2 equal sections, okay? What is a segment bisector? It's something that breaks a segment into 2 equal sections. So let me give you the actual definition here. It says this: segment bisector is any segment, line, or plane that intersects a segment at its midpoint. Okay? Any segment, line, or plane that intersects a segment at its midpoint. So if I were to go ahead and draw this out, drawing a line here, or a line segment, okay, anything that passes through this midpoint right here would be a segment bisector. Well, that could be, and I didn't draw that very well, okay, that could be a line segment, okay? That would break that segment into 2 equal segments. It could also be a line, okay? Rarely do you see a plane forming a segment bisector. It's usually either a line or a line segment forming that, intersecting at that midpoint. So I hope that makes sense. We're going to be talking about midpoints primarily, but we're going to figure out where the points are located elsewhere on a line. All right, so let's go to our first example here, real-world example. It actually happened to me this last summer. My wife was asking me to hang a picture for her, and she wanted me to, here's where I want the picture, Brandon. Well, you figure out where to put the nail. Well, here's what's going on. If I go ahead and pull that up, the problem, where is it? Right there. Okay. So this isn't the exact problem, but it was very close. This past summer, my wife had me hang a couple of pictures on the wall. In one such situation, the closest corner of the picture frame was 30 inches from the wall. So this length right here was, and see if I can get my pen tool to come up. There we go. This length right here was, I didn't do that very well, but that was 30 inches. Okay? And then it says the other corner of the picture frame was 45.5 inches from the wall. So if I go ahead and do this, right there, 45.5 inches from the wall. Okay? And so the question is, number one, if the picture frame hangs from a string that is connected to both sides of the picture frame, at what distance should I put the nail from the wall to hang the frame? Okay, so here's what my wife did. About right here, she attached a piece of metal string. Over here, she attached another. And then from there, she just ran that metal string from the one point to the other point. Okay, so the question is, where do I put the nail? Well, I hope that you're thinking it's got to be in the middle point between A and B. Now, how do I figure out where that point is? Well, one way to do it is kind of like we just got done talking about. If you go ahead and take the average of those 2 lengths, the average, that should be where I should locate my nail. Okay? So if I add those together, 75.5 inches over 2 ends up being, if we calculate that out, 37.75 inches. Okay, so right here, I'm going to estimate here. Let's say that point where I'm going to put that nail is going to be right there. Okay, and so if that's the midpoint, okay, then what we should know is that if this is 30, then this right here from A to that point right there is 7.75 inches. Okay? And if we think about it from the midpoint to B, if I can do that, midpoint to B, okay, what should this length be over here if that's the midpoint between A and B? Well, if you add 30 and 37.75, and subtract that from 45.5, what you're going to see is this. Oh, is it going to work? 7.75 inches. Okay? And so, yeah, that's what we're looking for, the middle point. Now, the other thing I had to consider, because when we hang pictures, and guys, you'll find this out when your wives want you to hang your pictures, it's just nothing I had ever thought of before, but what else did I have to consider prior to placing the nail in the wall to hang the picture? Because I'm one of those guys that does not like to fill nail holes in the wall. I make a spot, I want it to stay there for a long time. And so what else should I consider when putting a nail into the wall? Well, I guess the biggest thing is how much slack I have right here on this line. If I have a lot of slack, I'm going to want to put that nail probably up the way a little bit. Okay? There's not a lot of slack, I put it right there because my wife wants that picture frame right there, and we don't want to deviate from that. Okay? Now, this next problem down here, the temperature problem, very similar to what we just got done doing. Take a moment, figure out the middle point temperature, the midpoint temperature between those two temperatures, and record that in the Edpuzzle video, and we're going to keep moving along. Hopefully that first example made sense. Okay, hopefully you got that recorded into the video and ready to move on. Next thing we're going to look at is how to locate the midpoint on the coordinate plane. So let's read through this one. It says, find the coordinates of M, the midpoint of ST. Now, if I was to draw a picture out of what we're doing here, we've got this point here, and here's S, and here's T. And we want to find M, and I'm just estimating here. Okay, this is M, and it's the midpoint of ST. So this length here needs to be the same as this length here. Okay? So S, we're told, is at -6.3. So on your paper there, 1, 2, 3, 4, 5, 6, 1, 2, 3. Okay. So we make that point, if I can, and that's point S. T is at 1, 0. So if I go ahead and mark that point, 1, 0. Okay, now if I were you, I would go ahead and connect those two to each other. Now, I wasn't able to be super accurate. In fact, it's kind of funny if you were to watch my video right now. For some reason, my board isn't calibrated to my pen. So my pen is about 3 or 4 inches off of where I'm actually drawing a line, and it's really hard to place that line accurately. If I were you, I would draw it with a straight edge, okay, or a ruler or something like that, because the more accurate you are drawing this line, the more your final answer will make sense, and I'll point that out in a second. So one way to go ahead and solve for the midpoint between S and T is to use the midpoint formula that we just said. Now, before I do that, I'm going to go ahead and put down x sub 1 and y sub 1 for the -6 and the 3. And I'm going to put down x sub 2 and y sub 2. So this one's the y sub 2. Okay? It's really funny watching me try to write that because I'm having to look underneath my hand about 4 inches over if my pen is actually showing up there. I hope that makes sense to you because it's kind of funny to me. Anyways, if I go ahead and plug these values in, here's what the midpoint formula says. You have your x sub 2 value, which is 1, and we're going to add in the x sub 1 value, which is -6. And then we're going to divide that by 2. Okay, now before I go on and do my y value, I'm going to go ahead and simplify that out because I want to get confused between the x and the y. So if I go ahead and do the numerator here, 1 plus -6, I hope you're thinking -5. And if I simplify that, that's going to give me -2.5. Okay, ignore that right there. That wasn't supposed to be there. Okay, -2.5. All right. So what we're looking at is if I go over here and I count this off, 1, 2.5, somewhere on this line right here, the vertical line is going to be that y value. To determine the y value, I'm going to go back to the y sub 2, 0, plus, and we're looking at the y sub 1 value, 3. And all that's over 2. Okay? And so if I simplify that, 3 divided by 2 gives me 1 1/2. Okay? And so as I look here, if I go to negative 2.5, 1, 2.5, go up 1.5. Now I know this is a little off. Right there's 1 1/2. That point is on that line. I just didn't draw it very accurately when I drew my initial line segment out there. Okay? And that is the midpoint between S and T. Okay? Now the question that usually follows that is, okay, Mr. Couples, what if I switch these two? What if I made these x sub 2 and y sub 2 and made this t value, over here, t value, I made that x sub 1 and y sub 1. Can I switch those two? Yes, your answer will be the exact same. So don't put the pressure on you, I got to choose the right point. No, it doesn't matter what point you choose. It's going to give you the final answer. Thank goodness. Okay? There's no word to that. You just have to come back to the original value. Okay? Now the other way that I wanted to show you guys how to figure out the midpoint between those is to go ahead and actually use the graph. Now I'm going to be honest with you. I like this better than using the formula. I'm more of a hands-on person, and I can see things more quickly by using my hands. If you're this type of person, by all means, go ahead and do that. But what I'm going to do is I'm going to graph the slope, the rise to the run. Okay? And then I'm just going to count the rise, and I'm going to count the run. Now, if I count the rise, starting at 0, 1, 2, 3. So that length is 3 right there. Okay? The run, this length is 1, 2, 3, 4, 5, 6, 7. 7. Okay? Rise the run, 3 to 7. Now, if I go back to my actual formula, let me see here. I see the 3. I don't see the 7 up here. I guess that wasn't going to work like I wanted it to. But here's what I want you to see. If I go halfway up the rise and halfway over on the run, where those 2 points meet should be my midpoint. So halfway up the rise, 3 is my vertical rise. So if I go up 1.5, the midpoint there, okay, somewhere on this line right here should be my midpoint. Okay. Now if I go halfway over on the run, 7 divided by half is 3.5. 1, 2, 3.5, right there. And what do we notice? This is over at 2.5 and up 1.5. It's the same spot. So I don't care how you choose to go ahead and figure out the midpoint. I think it's faster using the graph, but sometimes those points are going to be off the graph. Sometimes they're going to be huge numbers. Well, what do you do then? I mean, you can try to graph it. It'll take you a lot more time. You use the formula. So it's important to know both of those. I would probably create one of them as my go-to, but both of them will work. The formula always works. The graph, like I said, if it's off the graph, can be a little more difficult. So you choose what you like the best. Okay? I want you to take a moment, and I want you to do this second one on your own. Find the coordinates of C, that's the midpoint of AB. You've got A, which is at -8, -2, and B is at 5, 1. Take a moment and see if you can figure that out and place your answer in Edpuzzle. All right, hopefully that last problem worked out for you. I will tell you this, that point, that midpoint, I don't know if it goes off the graph. I do know that one of the points at least goes off the graph. Oh, I take that back. That's a different problem. So yeah, I hope that your point that you found made sense. That's a lot of things with geometry. Make sure your answer makes sense with the problem. So for example, in that last problem, our value of m was -2, 1 1/2. If by chance the value of m was, let's say, -5, -7, that isn't anywhere close to that line segment of the ST. So our answer has to make sense with the problem that we're working with. Okay? All right, now the next one. We have, let's see here, number 3, find the missing coordinates. Let's say you call a friend from Columbus and let them know that you'll be coming through town this weekend and would like to meet up. Is it possible to determine your final destination if we know that you started from Findlay and that Columbus is your midpoint? I'm not sure I worded that very well, to be honest with you. Here's what I really wanted to say, and I might have to relook at the wording here. I'm going to go ahead and attempt, I'm not the best artist, to go ahead and draw Ohio. Okay? Now don't laugh. Like I said, I'm not the best artist here. All right. I hope you can see it. That's Ohio. Okay? And let's say that Columbus is down here, and that Findlay is up here. Okay, so I'm going to put F is here, and C is here. Okay? Well, what I meant to say is, let's say you call a friend that's down in southeast Ohio. Okay, so somewhere down in here. Okay? And let's say that you decide to meet halfway in between, which is in Columbus. Could you figure out exactly where your friend is coming from? And the answer is this. If I go ahead and draw a segment, hopefully yours is straighter than mine, okay, and I make this endpoint down here. I have no idea what the town's name would be, but let's just say that that's X. If you know this distance from yourself to Columbus, then you also know this distance from Columbus to that X. Okay? And it all goes back to that understanding of midpoint. And so, keeping that in mind, I want to look at this next problem because that's what we're going to be doing. You're going to be given one endpoint of your problem. You're going to be given one midpoint, and you have to find the other endpoint. Okay? So, I'm going to give you two options here as we look at this. Let's go ahead and flip over to the next page. One option would be to use your formula. And so as I look at this next problem, if we use the midpoint formula, we should be able to figure out that other point. So it says this, find the coordinates of J if K is at -1, 2, and the midpoint of JL and L has the coordinates of 3, -5. So basically, let me just make sure we understand this. Okay. If K is the midpoint, that's the big thing there. So you might want to just highlight this right here, if K is the midpoint. So you have J, I'm going to draw my segment up here so you can understand what's going on. So you have this segment, this is J, this is L, segment JL. And K is located in here. Okay? And so the ordered pairs would be this. K is at -1, 2. And then we know that L is at 3, -5. And the question is, can you figure out what, oops, let me go back one. Can you figure out what J is going to be? Okay. All right. So if I use the formula, here's what I would put down. Let's say that this is X sub 1 and this is Y sub 1. And this is your X midpoint. MD, PT. Okay, and then this is your Y midpoint. Okay. Now if you remember from our formula, if I go ahead and use the X sub 2, so I'm just going to put down X, plus X sub 1, which in this case would be 3. So that's where I'm getting that from. Over 2, whatever that is, that has to equal my X midpoint. So I'm going to put down here -1. Okay? Now let's just talk real quickly about how to go ahead and solve this type of problem. I've been seeing a lot of you do a lot of good algebra work where you know that you're dividing this expression, X plus 3 divided by 2, to undo the division you can multiply. Okay? Some people get a little confused with this, and so what I tell people when they have this type of problem is to go ahead and put this over 1 and just cross multiply. So with the top there and this down here, okay? And so if we do that, we have x plus 3 times 1. Well, the x plus 3 remains the same, okay? And you have the 2 times negative 1. Well, what is 2 times negative 1? You have negative 2, okay? So cross multiply there, cross multiply there. Again, anything times 1 is still itself, so nothing changed there. If I go ahead and finish this off, minus 3, we have that x will equal negative 5. Okay? Now I'm going to repeat that same process for the y value. So the y value will look like this. We have y sub 2, I'll just put y, plus y sub 1, which is negative 5. All that's over 2, and that will equal, whatever we get here, will equal the y midpoint, which is just 2. Okay? Now again, I can go ahead and put this over 1 if that helps out, and then just cross multiply. So you end up with this, y basically minus 5. Y minus 5 times 1 is just still y minus 5. 2 times 2 is 4. Okay? If I go ahead and add 5 to both sides to get y by itself, we end up with y equals 9. Okay? So this right here is your ordered pair. You have x equals negative 5, y equals 9. How do I double check myself? Well, what I'm going to do here, and this is how I usually find that third point. It's easier this way, but sometimes it goes off the graph. You'll notice in the next one, your other point is actually going to go off the graph. So G, we're trying to locate G in this next one. It's going to go above the graph here. So be careful as you try it using the graph. But if I go ahead and graph the 2 points, 3, negative 5, 1, 2, 3, 1, 2, 3, 4, 5, right there. Okay? So that is going to be my point L. Okay? My midpoint is at negative 1, 2. So negative 1, 1, 2. And on the last problem there, guys, I told you, let me go ahead and put that down, that's K. I told you to make sure that your final answer makes sense with what you're doing. So right now, if I get a point way over here, there's no way that that point can be on this line segment, okay, or this line. It's got to be somewhere up in here that we're looking for. Now, what I would do is, if you take a look, if you count the rise and the run, 1, 2, 3, 4, 5, 6, 7, and over 1, 2, 3, 4. Up 7 and over 4. If I go that same rise and that same run, the distance that I'm finding here, let me change colors real quick. The distance I'm finding here, okay, should be the same on the other side. So again, I'm going to go up 7, 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4. Okay, that point right there should be the point I'm looking for, that point right there. Okay, so this length here should be equal to that length there. Okay, now let's see if that answer, this answer, agrees with what we found down here. Okay, so if I count over, this is going to be over 1, 2, 3, 4, 5. Well, that's good. I've got negative 5. And then up 1, 2, 3, 4, 5, 6, 7, 8, 9. Very good. Okay. I will tell you this, that doing it this way right here, oh, goodness, my pen's way off. Doing it this way right here is going to be a little bit more confusing, but again, it always works. Doesn't matter if the points are on the grid or not. This way down here, okay, you're going to have to, or I'm sorry, this way over here, counting the rise and the run, 7 and 4, they're the exact same. Works great if the points are on the map, or on the grid. So Anyways, go ahead and do that next one for me. Like I said, it's going to be off the grid a little bit, but if you keep making your tick marks accurately and counting things correctly, you can use either method. It doesn't matter. Okay? All right, so I hope that worked out for you, that last problem. Where we're moving on to now is you're giving a segment, and you have to go ahead and convert it into an equation that will allow you to figure out the value of whatever variable you're looking at, okay? Now, what I want to do for this one, I think I want to skip the first one because it's a little bit easier, and you can come back and do that one here in a little bit, okay? Let's go down to the next page. Let's actually draw this problem out, and then let's talk it through how you should solve for x in this problem, okay? So in this problem, it says find the value of x if C is the midpoint of AB. So what I'm going to do is I'm going to first of all go ahead and draw a line segment and put C as my midpoint. A, B, okay? Now, we're told that AB is going to be 78. So this whole length here, from here all the way over to here, is going to be 78 units. So I'm going to go ahead and do something like this. Okay? And we're also told that AC is going to be 4x plus 5. So I'm going to put that here, 4x plus 5. Okay? Now, we still need to do one more thing, knowing that that's the midpoint. The midpoint tells me that this length here is equal to this length here. And then the question is, from there, what's the equation that we're going to use? Okay? Well, there's several options you can use here, several different directions you can go to figure out what the equation is going to be. One direction would be to go ahead and say, you know what, if I go ahead and add up 4x plus 5 plus 4x plus 5, that's going to equal 78. And all we're doing there is the segment addition postulate. Adding one segment plus the other segment equals the entire segment. Okay? However, it might be a little bit quicker and easier to go ahead and say this. You know what? If I know the length of AC, 4x plus 5, and I know that AC has to be equal to BC, then I can double this length, and that will have to equal the entire length. Okay? That's using more or less the definition of midpoints, the middle point. Both values are the same length. Okay? So again, you can probably do this faster than I can write it down, but if I go ahead and solve for x, we're looking at 10x plus 5 is equal to 78. And then from there, we're going to subtract 5. 10x is equal to 73. Oh, 3, sorry. Okay. And then you want to go ahead and divide through by 10 to know that x is equal to 7.3. Okay, 7.3. Now I always go back to my problem and ask myself, okay, what were we really looking for here? I've solved for x, but is that the answer? And if I look up there, all we needed was the value of x. And so, nice circle. We're done. If it did say I want the value of, let's say, CB, the length of CB, you'd plug that 7.3 into 4x plus 5 and simplify that, and then that would give you the length of CB. Okay? Or you could just take, now I think about it, half of 78, and that would be the length of CB. Okay? Now, I do want to give you a couple of hints before you go ahead and do this next problem. And so if I go back to that problem there that we just skipped over, it's a little bit easier than the one we just did. But here's what I would put down. Find the measure of PQ. So one of the things I'm going to do on my paper is I'm probably going to circle this right here. That's what we're trying to find. If Q is the midpoint, so this is also important, of PR. If Q is the midpoint of PR, I know that this length here and this length here have to be the same length. So right now, you should already know what the equation is to solve for y. Okay? You don't know what y is, but you can at least set up that equation if PQ equals QR. Now, I'm going to continue to think out loud with you to make sure that you can't get this wrong. Understand that PQ is 9y minus 2. And understand that QR is 14 plus 5y. So what are you going to do to show that PQ is equal to QR? I hope you know what to do. Once you have y, you then need to substitute it back in to figure out what the length of PQ is. Okay? Good luck. Good luck. All right. Finish that problem up for me, and then rejoin me for the last two examples. Okay, so I must have lied. I think I have 3 examples here now that I'm thinking about it. Example number 5 says this. We're going to locate points at fractional distances. Oh, that's like a cuss word. That's like a cuss word. Don't use the F word in math. Fractional. All right, believe me, it's not that bad. Let's talk about it. Find x if AF, of AF, if, excuse me, I need to go back to reading school. Find x of AF that is 1/6 the distance of AF, okay? So what we're looking at here is this. From here to here, we're going to go 1/6 the way away from -7. I'm going to figure out where that point lies and then know where that point x is going to lie. So what I'm going to do first is figure out the distance from A to F. Now, if you remember from the other day, you can count this distance. If I do that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Total distance is 12. Or I can say, hey, I've got 5 units to the right of 0. I've got 7 to the left. 5 plus 7 is 12. Okay? So this whole length here is the length of 12 units apart, A to F. And we want to know where x is located if it is 1/6 the distance from A to F. Now this is key here, and I'll show you why in just a second. So if I start with the total length from A to F is 12, and I want to know what 1/6 that distance is going to be, I'm going to multiply it by 1/6. Okay? Now you need to think like this. You can plug that in your calculator, or if you multiply straight across and multiply straight across, okay, the distance that would be 1/6 away from A to F is going to be 2 units away from A. Now the question you want to go with next is this. Am I going to go 2 units in this direction? Or am I going to go 2 units in this direction? I hope you chose the first one, because if it's a point that's 1/6 of the distance from A to F, we know we're going from A to F, so we're going in that direction. All right. So if I'm going to do that, I'm actually going to add two points to it. So I can either count it, 1, 2. So this point right here is where x will be located at -5. Or I could take my end point, and since I'm going 2 units to the right, which means in a positive direction, I can add it, and you get -5 either way. That's where x is going to be located there. Okay? So take a look at the next problem. We want to find the point on CE that is 1/8 the distance from C to E. So if you need to, go back and rewatch that portion of the video. But pretty simple. Use your fractions wisely. Okay? All right. This next problem is one that I have seen on the air test before, so it will be very important that you guys can know and understand how to do this problem. So it says here, we want to, example 6, fractional distances on the coordinate plane. You need to think in 2 manners, a vertical manner and a horizontal manner. Let me just explain what's going on. Let me change my color on my pen tool first. Go to red, stand out a little bit more. Okay. So as I look up here, it says find R on NM. So here's NM right here, okay? R is somewhere on this line segment. So if you get an answer for R that's out in here or up in here, you've done something serious wrong, okay? That is 1/4 the distance from N to M, okay? Man, how do I figure out 1/4 the way up this line segment? Well, here's what I'm going to do. I'm going to actually count the rise and the run, the slope between these 2 points. So if I do that, 1, 2, 3, 4, 5, 6. This is a length of 6. 1, 2, 3, 4, 5. This is a length of 5. Okay? Now, if I'm going to go to a point that's 1/4 from N to M, I need to go 1/4 the way up the line and 1/4 the way over on this line, and that point will be where I need to go. Okay? Don't go 1/4 the way up and 1/4 the way over, because when your lines come together, you'll be somewhere over in here. You don't want to do that. Okay? So if I take the vertical distance, the rise, from point M, 6 is the vertical rise, and I'm going to multiply that by 1/4. Okay? If I do that, remember, you can put this over 1 and multiply straight across. 6 times 1 is 6. 1 times 4 is 4. And so you end up with 1 and 1/2. Okay? That's how high up we want to go from N, because we're traveling from N to M. So we're going to be going up this direction 1 and 1/2 units. So 1 and 1/2 right there. Okay? Now the horizontal distance, I'm going to start from here because I'm going from N to M. The horizontal distance, I've got to figure out that too. So I'm going to do 5, and I'll put it over 1, times 1/4. If we work that out, 5 times 1, 1 times 4. This is actually 1 and 1/4. Man, fractions everywhere. Jeez. All right. Well, let's go ahead and do this. If I go ahead and count this over, 1 and 1/4, I'm just estimating it here, somewhere right in here. Somewhere right in here. Okay? So you can tell where those two lines meet, this point right here is on this line segment, so I've done a good job. Now the question is, how do I get to that point? Well, if you notice, I would just go ahead and take this x value, and since I'm going up 1 and 1/2, I would just add it to that. So I've got the x value, and I'm going to add the 1 and 1/2, because that's the rise. Okay? So if I take 3 plus 1 and 1/2, you can type that in your calculator if you want to, but basically I've got -3, -2, -1 and 1/2. Okay? So that's what we're looking at here, -1 and 1/2. For the y value, I'll do that over here, you're going to do the same thing, because we're going to the right, we're going to add that distance right there. So if I take -3 and I add in 1 and 1/4, that should give me the new y value. Now, think about this for a second. If by chance you were going down from a point, you'd want to subtract. If you're going to the left, you'd want to subtract. That's why I'm adding, is because I'm going up and I'm going to the right. Just something to think about. Okay? So if we do this, -3, -2, -1 3/4. And so in the end, you've got your x value. Now we've got to be careful here. Which one was our x and which one was our y? Did I just do that wrong? Let me think here for a second. I just did that wrong. I told you guys incorrectly. Let me rephrase. The answers are still the same. The problem I should have done is this. I didn't think about this as I was working it out with you. Let me explain. Okay, so what I should have thought of as I was working this out is this. This is the vertical distance. We're going up 1 and 1/2. So what I should have done is taken the y value, because the y value is the vertical. This is our horizontal distance, remember, over 1 1/4. So I should have taken my horizontal value. Okay, so be very careful with that as you try this next one here. Okay, and so in the end, our x value, let's make sure here, 1, and then it's almost 2, so 1 3/4, we've got that, negative 1 3/4. And then the y value is going to be down 1 1/2. So negative 1 1/2. Okay? So I didn't mean to confuse you on that. I apologize if it did. Maybe you want to go back and rewatch that, just that end part there. But those are some good notes there. So I want you to go ahead and try the next one for me. I've already laid out the rise and the run, 6 and 5. You need to figure out a point that's 1/5 the distance from N to M. Okay? All right, hey, you guys have been a great audience today. I appreciate you working hard. You know, a lot of times when I was in school, it was sub day, blow off day, you know, and you know, whenever your teacher comes back, you can do the work again. But I appreciate you putting in the time. I really do. The last example I have is locating a point given a ratio. Okay, and so I need to explain that part really clearly. Again, this is a problem I've seen on the air test. I want to make sure you guys can knock this out of the park because it's not that hard. It says find C on AB such that the ratio of AC to CB is 1 to 4. Okay, and so what I would make a note of, and I'm not going to write it out on the board because it does get kind of sloppy as I write this out. Maybe I will. Okay, this part right here, I want you to write down 1 part AC, and then this part right here, we're going to say is 4 parts CB. Okay, looks like C13 CB. Love technology. All right. All right, so how do we figure out where this point is located? Well, what I want you to write down is this. If we're going from A to B, I want to know how many total parts are possessed on that line segment. How many total parts are contained if I have 1 part AC and 4 parts CB? Okay. Well, if you think about it, if I add those two together, there are a total of 5 parts along this segment right here. 1 part up here and 4 parts down here. And so what I'm going to write down is this. If I want to know where that point is located, I'm going to put the AC to CB, or to AB. To AB. Okay. Now what that ends up being is 1 part AC and 5 parts for the whole length of AB. What I'm doing here, guys, is this. I'm converting it back to the old type of problem that we just had. Okay? So it would be like this point C is located 1/5 the way from A to B. Okay? You can picture that. So now I'm going to go back and do what I did before. I'm going to do my rise to run. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay? Now, I'm starting at A, and we're going down to B. So what I'm going to do is this. My vertical rise is 4. So if I take 1/5 of that, I get 4/5. Okay? And my horizontal run is 5. So I have 1/5 of that. 1/5 of 5 is just 1. Okay? So what this looks like is this. If I move over 1, right here, okay, C has to lie on that red line somewhere. Okay? If I go down 4/5, so not quite a whole 1 right here, we draw that across. That point right there should be where point C is going to lie. Okay? Now what's the ordered pair for that? Well, since I'm going right from A, I'm going to add the 1. So here we're at, what are we at? -4, +6. So if I go from -4, this right here is -3. Okay? So again, -4 plus 1, -3. Okay? And I'll even put over here that A's coordinates are -4, +6. Okay. Now for the, that'd be the horizontal, the x values. The vertical is the y value. So if I go ahead and take the y value, 6. Now you'll notice here that we're going down to get to the c. So I want to subtract. If I go left, you subtract. If you go down, you subtract. So I'm going to subtract 4/5, that length that we just found. Okay. And if you plug that in your calculator, this is 0.8 right here. So 6 minus 0.8 gives you 5.2. Well, let's see if that works. Or 5 1/5. 5.2. If I go over the x value, -3, 1, 2, 3, up 5 1/5. 1, 2, 3, 4, 5 1/5. Bingo. There's our value we're looking for. Okay? So again, these last two examples have been a little more in depth, but they are going to be key on your air test. I'm excited that we're covering them this year, and you're going to have a lot of different times to go ahead and figure out how to do these type of problems, because they are going to be key. Some of you going from a 2 to a 3, a 3 to a 4, or 4 to a 5 could really do well with that. So go ahead and try the next one for me. Find D on AB such that the ratio of AD to DB is 1 to 3. Okay? Take a moment, see if you can do that. When you're done, come back or insert your answer and then come back and talk to me. For the last problem there, it says describe the difference between finding a fraction of a total distance and finding the ratio that an interior point of the line segment. Basically, I wanted you to describe the difference between the last two. And the biggest difference, I believe, is that in this last example, we're talking about 2 parts of a line, 1 part AC, 4 parts CB. So you got 2 parts of a line versus the previous example, number 6, where we were given, let me see here. I want to give you the exact numbers. Where did it go? Oh, there it is. Where you were given the distance from N to M, R would be 1/4 the distance from N to M. So the difference is, in example 7, you're given 2 parts along the same segment. In example number 6, you're giving the entire segment, the parts along the entire segment. So it's just 1 whole fraction versus 2 parts. So I hope that made sense. Talk to a friend. You guys can discuss it. But when you get done here, you do have some examples I'd like you to work out on your own for homework tomorrow. Have those done for me, and we will talk about them. Thank you. I appreciate your attentiveness. That was a long lesson. But I look forward to seeing you guys tomorrow and seeing how you did. Thanks. Good night.